And if you notice, most of these questions, actually all of them except one, have the A value not being 1. So you're going to have to modify the pattern 1, 1, 2, 4, 3, 9 on every single question except for number 10. You don't have to modify the pattern on number 10. Or you could use a table, of course. So number 7, what's the vertex? Knowing vertex form is you think opposite on H and you take K for what it is. What's the opposite of negative 4? 4. And then K, you take it for what it is. So the vertex is 4, negative 6. Let's all graph 4 on the X, negative 6 on the Y. And let's put a dot right there. 4, negative 6. Second step to graphing any parabola is to draw your axis of symmetry right through that vertex. And the second thing I asked for is the axis of symmetry equation. And the axis of symmetry equation is X equals that X value of your vertex, which is 4. That's where the line goes through. It goes through the X value of 4. It doesn't go through the X value of 1. It doesn't go through the X value of 6. It goes through the X value of 4. So your axis of symmetry equation is X equals 4. So ladies and gentlemen, you're going to get several points for each of these, right? You get 1 point for the vertex. You get another point for axis of symmetry. Now let's go. We need more coordinates, so we either use a pattern or a table. I want to do both just so you guys could get to choose which one you feel more comfortable with. So if we want to use a table, you're going to make an XY table. Actually, let me zoom in a little. So if I want to use a table, you need to plug in some easy numbers for X and pull out some numbers for Y. And you want values to plug in that are on the same side of the axis of symmetry. So give me 2 numbers that are on the same side, very close to this X value of 4. 5 and 3, that's kind of not a good idea because you're going to be able to reflect it over anyway, right? So how about 2 points, 2 values that are on the same side? So 3 and 2 are good values. 3 and 2 are good values. So let's plug in a 3 and plug in a 2. Guys, please quit talking. Pay attention. So when I plug in a 3 for X, it's going to say 3 minus 4, which is negative 1. And then negative 1 squared is positive 1. And then positive 1 times 2 is 2, and 2 minus 6 is negative 4. And the other input that we have right here is 2. Let's plug in 2. What's 2 take away 4? That's negative 2. Negative 2 squared is positive 4. Positive 4 times 2 is 8. 8 take away 6 is 2. So as you can see, it's not difficult at all to use an XY table. Let's graph the coordinate 3, negative 4. That's 3 on the X, 1, 2, 3, negative 1, 2, 3, 4. It's right here. Let's go 2, 2. That's 2 on the X, 2 on the Y, which is right here. And you have those points, map them over to the other side, and you'll get that coordinate, and we're done. We have that perfect graph. It is slightly narrower than your regular U-shaped curve. That's because the A value is further away from 0 than the A value of 1. Anyhow, we used the pattern right here, but you didn't have to use a pattern. You could have, we used a table. We used a table, and we could have used the pattern. Let me show you how to use the pattern. The pattern is usually 1, 1, 2, 4, 3, 9. That's the usual pattern when your A value is 1. But right here, your A value is 2. So obviously, that 2 is going to change the pattern. It's going to change the second values, the outputs of the pattern. It's going to change by modifying it by 2. So what do I mean modifying it by 2? This 1 is going to become 2 because I need to multiply it by 2. That way I get the answer 2. The 4 times 2 will change to an 8. The 9 times 2 will change to an 18. So your new pattern is not really 1, 1. It's actually 1, 2. Your new pattern is not 2, 4. It's actually 2, 8. Your new pattern is not 3, 9. It's actually 3, 18. So you could use a pattern if you want, if you modify the pattern. So check it out. From the vertex, I want to go 1 over and 2 up. And I am going up because A value is positive. So from the vertex, 1 over and 2 up, we get to that coordinate. Then you go back to the vertex and go 2 over 8 up. So if you go 2 over 1, 2, 8 up, 1, 2, 3, 4, 5, 6, 7, 8, I get to that next coordinate right there. And I could go 3 over 18 up, but if I go 3 over 18 up, I'm going to be off the graph. So I'm good right there. So it's up to you. I did both ways. I did the XY table and I did the modified pattern That way you guys get to choose and see what you're more comfortable with, okay? So it's totally up to you. What else do we need to answer to get more points to the domain? X equals all real numbers. You have to use the X. If you don't put X equals, you only get half credit. The range, Y is what? Greater than or equal to or less than or equal to? Greater than or equal to, because the parabola is opening up, right? And it's greater than or equal to the Y value of your vertex. So what's the Y value of your vertex? -6. So there's your answer for range. How about the X-Intercepts? Where does it cross the X-axis? It crosses the X-axis at 1, 2, 2.1, right? Just about. And we're going to use approximation symbols. And also 1, 2, 3, 4, 5, about 5.6, 5.7. The Y-intercepts, where does it cross the Y-axis? Well, here's the Y-axis. Some people say it doesn't cross, but it does, because it keeps going this way, and at some point, it's going to cross that Y-axis. So if you can't see it visually, figure it out algebraically. And again, to figure it out algebraically, you might want to jot this down. Set x equal to 0, and then solve. So go to your original equation and set x equal to 0. So you have 0 minus 4, that's -4. And -4 squared, that's positive 16. And then 16 times 2, 16 times 2 is 32. And then 32 take away 6 is 26. So the actual Y-intercept is at 26. The X-intercept was at 2.1 and 5. The Y-intercept, it doesn't cross till 26, way up here somewhere at 26. So on the quiz Friday, yes, you're going to have to graph parabolas. Half of them are going to be in vertex form. The other half are going to be in standard form, where you actually have to use a vertex formula to find the vertex. And everything else you graph exactly the same. And you will get 1 point for each of these. You get a point for the vertex, a point for the axis of symmetry, a point for the pattern or the XY table, a point for the domain, a point for the range, a point for your X-intercepts, a point for your Y-intercept, and of course a couple of points for your graph. Let's move on. Number 8. What's the vertex? Jumping to number 8. The vertex is 1, 4. No, wait, what? Number 8? What's the vertex? Think opposite on H. Yep, -3 for H, +4 for K. That's your vertex. Let's go -1, 2, 3, and +1, 2, 3, 4. Put a dot right there. Draw your axis of symmetry right through it. The axis of symmetry equation is, you have to put x equals. If you don't put x equals, you don't get full credit for the axis of symmetry. And of course, it's going to be the x value of your vertex, which is -3. And that is the axis of symmetry. Now we need a pattern or a table. You guys want to do both so you could see both, or do you want to pick one? Pattern? Okay, so if you want to use the pattern that we have memorized is 1, 1, 2, 4, 3, 9. However, we need to modify the second numbers on each of these pair of numbers, right? Why is that? Because the A value is not 1. This is the pattern for the A value of 1. If the A value changes, these second numbers are going to change according to that A value. Now, I'm not going to multiply 1 times -1/2, because the negative just tells me I'm going to be going down, and we already know that. So I'm going to say 1 times half. So if I zoom in right here and modify the second numbers by multiplying by half, I will get 1/2. I will get what? 4 times half is what? 2. 9 times half is what? 4.5. So here's my modified pattern. 1, 1/2. 2, 2. 3, 4.5. That's my modified pattern if you want to use a pattern. Some people find that confusing. Don't use a pattern if you find that confusing. Use an XY table if you find that confusing. But anyway, with that pattern, I am going to go 1 over and half down. Okay, so 1 over and only halfway down, and we put a dot right there. And then we go 2 over, 2 down. So 2 over, 1, 2 down, and you're at a nice coordinate right there. Then go back to the vertex and go 3 over, 4.5 down. 1, 2, 3, 1, 2, 3, 4.5 is halfway down right there. Let's map those blue dots over to the other side of the axis of symmetry. Right here at the middle waypoint, right here at the nice coordinate, and over here at the middle waypoint. Connect the dots, and you will see that this parabola is slightly larger, wider than the usual parabola, of course, because the a value is 1/2, which is closer to 0 than the a value of 1 is. So that's our graph. We use the pattern. You could have used the table, right? Just a quick little example on the table. You could plug in any numbers you want for x that are pretty close to the x value of the axis of symmetry. So for example, if you plugged in the number, let's say -2, right? If you plugged in, let me write that down, -2, -2 for x plus 3 is 1. 1 squared is 1, and then 1 times -1/2 is -1/2 plus 4, that would be 3.5. So -2 comma 3.5 is a coordinate. So if I do go to -2 and then 3.5, I get to that coordinate right there. So you could plug in numbers, pull out answers if you want to use the XY table, or you could modify your pattern to use the pattern. Let's move on. The domain, we already know domain's x equals all real numbers. We already know the range is y is what? Less than or equal to, because it opens down. What's the y value of the vertex? So y is less than or equal to 4. That's the range. How about the x-intercept? Where does this cross the x-axis? Of course, we're going to do decimal approximations here, so let's put the squiggly equal sign. Why is it decimal approximations? Because it doesn't cross exactly at that value. It crosses at -1, 2, 3, 4, 5, almost 6. So what decimal is almost 6? -5.9. That's a good one. And then how about this guy over here? It's almost at 0. -0.1, -0.2. Sure, any one of those is good. -0.1. And last but not least, we need to state the y-intercept. Where does this cross the y-axis? We'd have to give -0.5. That's right. So if you did want to do it algebraically, plug in a 0 for x, and you'll see that you get out the -0.5 or -1/2 as the y. So you could say y-intercept is 0, -1/2, or you could just say y-intercept is -0.5 or just -1/2. Let's move on to number 9. On number 9, our vertex is HK. You think opposite on HK for what it is. So what is our HK value? +1, +4. That's right. So let's go to the vertex 1 on the x, 1, 2, 3, 4 on the y. Put a dot right there. And then, of course, the next thing to do, step 2 on any parabola after finding the vertex, is to draw that axis of symmetry right through it. And that axis of symmetry, you have to give me the equation of that axis of symmetry to get credit. That's x equals the x value of your vertex, which is 1. And then you need to use a pattern or the table, XY table, bless you, to be able to get more coordinates, right? So you could use a pattern, you could use a table. I want to do both so you guys could select which one you feel more comfortable with. So if I wanted to use an XY table, right, pretty tiny because there's not much space, I want to plug in values that are close to the x value of my axis of symmetry, that are not too far away from it, that are on the same side of it. So for example, if I plug in a 1, let me plug in a 1. Actually, no, I already plugged in a 1. That gave us the vertex 4, output 4. So let's plug in a 0 or plug in a 2, right? Let's do 2. 2 works out pretty good. When we plug in 2, 2 minus 1 is 1, and 1 squared is 1, and 1/2 times 1 is 1/2, and 1/2 plus 4 is 4.5. So when I plug in 4, I get a 4. When I plug in a 2, I get out 4.5. I can plug in a 3 now. If I plug in a 3, 3 take away 1 is 2, 2 squared is 4, 4 times half is 2, and 2 plus 4 is 6. Could also plug in a 4. If I plug in a 4, it's going to be 4 minus 1, that's 3. 3 squared is 9. 9 times half is 4.5. And 4.5 plus 4 is 8.5. That's a lot of math, a lot of opportunities for mistake. If you like XY tables, that's good. These are actual coordinates. Let's go to the coordinate 2, 4.5. So when I go 2, 4.5, I go 1, 2 on the X, 1, 2, 3, 4.5. That's halfway up. So let's put a dot right there at halfway up. Then the next coordinate is 3, 6. That's easy. 1, 2, 3, 1, 2, 3, 4, 5, 6. It's right there. And the last coordinate is 4, 8.5. So you go 4, 1, 2, 3, 4, 8.5. That is 8. And then 0.5 of the way up is just a little bit more. So let's put a dot right there. Does that make sense to everybody? Let's map those points over to the other side. Right here at the halfway point, right here at the nice coordinate, and right here at the halfway point off the graph. Connect those dots, and you will have graphed your parabola. So that's using the actual XY table. I plugged in numbers, I plugged in a 2, I did the math, I got out of 4.5. So you don't have to use an XY table. You could use a pattern. So let me zoom in and show you the pattern. The pattern that we're used to is 1, 1, 2, 4, 3, 9. But that pattern is only for when your A value is 1. And our A value here is what? What's our A value here? 1/2. Which means that A value is going to change the output values of this pattern. So I need to change this 1 by half, which means I want to multiply it by half because that's our A value. Multiply the 4 by half, multiply the 9 by half, and we're going to get our new outputs of the pattern. So instead of 1, 1, it's going to be 1, 1/2. Instead of 2, 4, it's going to be 2, 2 because 4 times half is 2. So instead of 2, 4, it's 2, 2. 9 times 1/2 is 4.5. So instead of 3, 9, it's 3, 4.5. That's our new pattern. So you could either use the XY table that I originally did and doing all that math, or modifying your pattern according to your new A value. So it's up to you. Whatever you feel more comfortable with, go for it. Let me show you how it would have worked out if I would have used a new modified pattern of 1 over, 1 halfway up. So if I go 1 over from the vertex halfway up, I will end up at that blue dot. If I go 2 over 2 up from the vertex, 2 over 2 up, I end up at that blue dot. If I go 3 over 4.5 up, 1, 2, 3, 1, 2, 3, 4.5 is halfway up off the graph. And that's how I'd get those same exact coordinates. I'd map them over and I'd have the same parabola. So it's totally up to you using the pattern or the XY table. You choose. All right? The domain, x equals all real numbers. The range, y is either greater than or equal to or less than or equal to, depending if it opens up or down. It opens up, doesn't it? So that is greater than or equal to. And what is the y value of your vertex? It's 4. So the range is really y is greater than or equal to 4. Okay. How about the x-intercepts? Where does this cross the x-axis? It doesn't. So you put none. There are no x-intercepts. How about the y-intercept? Where does it cross the y-axis? Right here at this location, which is at the halfway point. So that's really 1, 2, 3, 4.5. So 4.5. Of course, you could have done it algebraically, right? What do I mean by algebraically? To find the y-intercept, you have to set x equal to 0. So put a 0 right there, and you'll have a -1 squared, that's +1. +1 times half is half, and half plus 4 is 4.5. So that's why it's 4.5, the y-intercept. So you get 1 point for each of these, right? The vertex is a point, the axis symmetry is a point, the pattern's a point, the domain's a point, the range is a point, x-intercept's a point, the y-intercept's a point. And you get a couple of points for graphing correctly, of course. Number 10, what's the vertex right there, guys? What's a vertex? H and K, think opposite on H. -2 and 0. -2 and 0. Let's go to -2 and 0. Let's put a dot right there. Let's draw our axis of symmetry equation right through that dot. And let's write down that axis of symmetry equation. What's the axis of symmetry equation? x equals the x value of your vertex, -2. That's right. And you have to put x equals. If you don't put x equals, you don't get full credit right there. How about a pattern or a table? Pattern is really easy, especially because the a value is 1, which means you can use 1, 1, 2, 4, 3, 9. So from the vertex, I'm going to go 1 over and 1 up, or 1 over and 1 down? Tell me. Up. Why? Because the a value is positive, so I'm going to go 1 over and 1 up. Let's put a dot right there. And then I go back to the vertex, and I go 2 over, 1, 2, 3, 4 up, and put a dot right there. Then go back to the vertex, and go 3 over, 1, 2, 3, and 9 up, which is 8, 1 more off the graph. You don't have to put that one, but I am going to. It's just 1 unit off the graph. And then mirror all those blue dots over to the other side of your axis of symmetry, 1 unit away right here. Let's put that dot. The other one's 2 units away. The one that's off the graph is technically 3 units away. Connect those dots. Now you don't have to connect them all the way off the graph, but the reason why I do those dots is to actually be accurate. When I point an arrow, I am pointing at those dots. Anyhow, you didn't have to use the pattern 1, 1, 2, 4, 3, 9. You could have easily, just as easily, made an XY table, input-output table, and started plugging in numbers that are close to your X value on the axis of symmetry, or the X value of your vertex. So you could have plugged in 0, for example, and 0 plus 2 is 2, 2 squared is 4. So when you plug in 0, you get out of 4. So 0, 4 is a coordinate, and then you'd map it over to the other side. So you could get coordinates either by using an XY table, or by finding your vertex and then using your pattern or modified pattern from that vertex. So the domain is x equals all real numbers, like always. The range is y is what? Greater than or equal to, or less than or equal to? Greater than or equal to the y value of your vertex. What's the y value of your vertex? 0. Okay, so once again, the range is y is greater than or equal to, y is greater than or equal to the 0 value. So the whole parabola is above the y value of 0. It does touch 0, but it goes back up. So it makes total sense that we say that all the y values of this parabola are greater than or equal to 0. They're all above the y value of 0. Okay? And again, the range is simply y is greater than or equal to, because it's opening up, and you use the y value of your vertex. This is the x value, that's the y value, so y is greater than or equal to 0. The x-intercepts, where does it cross the x-axis? -2, that's great. Sometimes you have 2 different x-intercepts. Sometimes you have to do decimal approximations. Sometimes there is no x-intercepts. How about the y-intercept? Where does it cross the y-axis? Right there at 4. You could see it visually, or you could set x equal to 0 and do it algebraically. Anyway, you get all those points for answering all that. Number 11. Number 11, the vertex is what on number 11? -2. Opposite on H, so it's going to be a -2, and take K for what it is, -3. So the vertex is -2 on the X, -1, 2, 3 on the Y. Put a dot there. You draw your axis of symmetry. Now, ladies and gentlemen, it was brought to my attention that some of us are getting confused with patterns compared to XY tables, all right? Now, if you do the XY table, let me zoom in a bit right here. If you do the XY table, those are going to actually be coordinates. Those are input and output values. So you want to plug in values that are close to your X value. So maybe -1 and 0, or you could just start out with the easiest number, 0. And when you do plug in 0, check this out. 0 plus 2 is 2. 2 squared is 4. With the negative in front is -4. -3 is -7. Right? So you could graph 0, -7. So 0, -7 is way down here.
Yes, sir.
And of course you could map that over to the other side, 2 units away, 2 units away, and you have your parabola. You have to also, it'd be a good idea to plug in -1 so you could get the coordinate right here so it could be precise. So if you plug in a -1, and you do the math, -1 plus 2 is 1, and 1 squared is 1, and -1 minus 3, that'd be a -4. So you get a negative 4. Now, what I want to get at here, guys, is if you use an XY table, these are actual coordinates. 0, negative 7 is the location on the XY plane, 0, comma, negative 7. Negative 1, negative 4 is the actual location on the plane, the coordinate negative 1, comma, negative 4. Okay, so let's go to negative 1, negative 4 to that location. Negative 1, 2, 3, 4, it's right there. Map the points over to the other side, it's right there. Connect your dots, you have a parabola. Now, if you're using the pattern, which you might want to use a pattern because the a value is negative 1, so you could use the pattern 1, 1, 2, 4, 3, 9. You don't even have to modify anything. Now, the pattern is from the vertex. The XY table are actual coordinates. All right, so keep that in mind. The 1, 1 is from the vertex, 1 over, 1 down, because the a value is negative. That's why we're going down instead of up. So 1, 1 is from the vertex, 1 over, 1 down. See, this is not a pattern from the vertex. The 0, negative 7 is actually the coordinate 0 on the x, negative 7 on the y. So XY table are actual coordinates. Pattern is a pattern from the vertex. So 1 over, 1 down, 2 over, 4 down. So 2 over, 4 down, 3 over, 9 down. 3 over, 9 down is going to be off the graph. You don't have to do that. That's your parabola. Let's just list everything else that we can. The axis of symmetry is x equals the x value of your vertex, which is negative 2. You get a point for that. The pattern we already did, or the table we did both. The domain, x equals all real numbers. The range, y is what? Greater than or equal to, or less than or equal to? Less than or equal to the y value of our vertex, which is negative 3. So the y value of our vertex is what we use for range. X-intercept, there's none because it doesn't cross. Awesome. How about the Y-intercept? Negative 7. Because it obviously crosses right here at the location negative 7 on the Y. Now, you could see it visually, or you could actually do it algebraically. How do you do it algebraically? You set x equal to 0 and solve. So if you plug in a 0 right there, 0 plus 2 is 2. 2 squared is 4. Minus in the front is negative 4. Negative 4 minus 3 is negative 7. So that's how we get negative 7 for the Y-intercept. Let's go for the last one right here, guys. Number 12. What's the vertex? 4, negative 8. Perfect. Let's go to the coordinate 1, 2, 3, 4, negative 8. That's way down here right on the edge. Let's draw the axis of symmetry right through it. The axis of symmetry is x equals 4, the x value of the vertex. What do we want to do? The XY table, or we want to use a pattern? Okay, you want to go for pattern, and then we'll multiply the second values of the pattern by 2, the new a value. So the original pattern that we have memorized is 1, 1, 2, 4, 3, 9. And like I said, we have a new a value of 2. So let's multiply the second numbers by 2, giving us the second values of our pattern. So we're going to have 1, 2, 2, 8, 9, 18. So instead of 1, 1, 2, 4, 3, 9, it's 1, 2, 2, 8, 3, 18. Okay, so that's our new pattern. So let's go to the vertex. Let's graph the vertex. We already did graph the vertex. Let's go with the pattern from that vertex. So the pattern is 1 over 2 up. Let's put a dot right there. 1 over 2 up. And then let's go back to the vertex and go 2 over 8 up. So if I go 2 over 1, 2, 3, 4, 5, 6, 7, 8, I'll be right there. 2 over 8 up. And if I try 318, it's going to be off the graph, right? If I go 3 over 18, that's 16, 17, 18 is going to be 2 units off the graph. You don't have to do this. I'm just doing it just to show you that it's right there. That's the 3 from the vertex, 18 up. And then let's map those coordinates over to the other side. 1 right there, 1 right there. You don't have to go for this one. Draw your parabola pointing towards those other points off the graph. And we have that pretty narrow parabola opening up. It's narrow because the a value is 2. It's further away from 0. The closer it is to 0, the wider it gets. The domain, x equals all real numbers. The range, y is what? Greater than or equal to negative 8. Perfect. And the x-intercepts? 2 and 6. Excellent. 2 and 6. This is not precise. This is exact. It crosses exactly right here at 2 and right here at 6. Perfect. How about the Y-intercept? Don't say that it doesn't cross. It does, but it's going to cross somewhere way the heck up here. Somewhere way the heck up here. So you can't see the Y-intercept, but you could find the Y-intercept algebraically. How do you find the Y-intercept algebraically? Set x equal to 0 and solve, right? So let's go and put a 0 right here where the x is at. What's 0 take away 4? -4. What's -4 squared? -4 times -4 is 16. What's 16 times 2? It's 32. And what's 32 take away 8? That is 24. So the Y-intercept is 24. What does that mean? That it's going to cross way up here at the value of 24, somewhere way up there, right? Anyways, we've answered every single thing that we can about this parabola. You'll get full credit for that. The test Friday, Quiz Friday, is going to be almost exactly like this. Good luck.